Okay, hello guys. Today we are talking about the next part about magnitude of a vector, okay? So let's move into the first slide. So what is a magnitude? We can set magnitude is as a length, okay? So like here is an arrow. We can set here you can use a meter rule to measure the length of it. Like here you're using your meter rule to measure. Maybe here is for 5 centimeter, okay? So we can set magnitude here of the vector is for 5 centimeter, okay? So here, the magnitude of vector v can be written as a modulus of v, okay? So we can just consider as the length of the v, okay? And also, if we have a vector AB, we can say the magnitude of AB is a modulus inside is a vector AB, okay? So that is a magnitude meaning right here. So we said magnitude represents for the length, so it must be always a positive number, or they have no length, so that is zero, okay? So here, that is a magnitude formula. Right here, we have a like an arrow. So first, we can just draw a right angle triangle right here. Okay, so we can cite here. Here it is, and here it is. So we can say maybe the vector v can be decomposed as x and y. Okay, so here we can say vector v can be represented as square root x squared plus y squared. Okay, that is it. So that is for the magnitude formula. Vector v equals to x squared root x squared plus y squared. Okay, that is it. And here we have a working example. Like here we have a vector a equals to 5, 12. Okay, so we can just identify the components here. X equals to 5, y equals to 12. So you can say here from the central point 0, 0 to 5, 12. So that is for here. You're just trying to draw a triangle here. So that here, the length is 5, here is 12. So because here is a right angle triangle, we can say that is for square root 5 squared plus 12 squared, that equals to 25 plus 144 equals square root 169 equals to 13, okay? So we can say here, the modulus or the magnitude of the vector equals to 13 units, okay? That is it. And here we have a negative sign trap, okay? So maybe here for b, the vector here equals to 93, 94. We can say that the vector b here equals to square root 93 squared plus 94 squared, okay? So we can write that as 9 plus, sorry, here's 9 plus 16 equals to square root 25 or equals to 5 units right here, okay? That means a magnitude of a vector, okay? Okay, and here we have a distance between the points. Like here we can set for vector AB, we can set equals to the xn minus x start. And here next is for yn minus y start. That is for 8 minus 2. And here is for 1 minus 5 equals to 694. Okay, so then you can just using the matrix formula, right? So you can just consider it as a triangle and the two sides is 6 and 4. And using the Pythagoras theorem, we can say that the length here equals to 36 plus 16 equals to square root 52, okay? So we can say here, the exact distance is square root 52 units right here, okay? So here's a deliberate practice for you. If you have your ideas, you can just pause the video and then do it yourself. But if you want to follow with me, you can keep on going, okay? So let's move into the first problem, like here, vector p equals to 8, 15. So for the magnitude of p, you can write it as magnitude p equals to square root 8 squared plus 15 squared. That equals to 64 plus 225 equals to square root 200 and for 89, right? Okay. But that is for 17. That is for first problem. And for second problem, you can say the vector q's magnitude can be written as 97 squared plus 2 squared, right? So here's for square root 49 plus 4, that is square root 53, right? Just using the formula, right? A squared plus b squared, okay? So for problem 3 is that m is for 93 and find the magnitude of 2m. So we can say here that is for 2m, right? We're just enlarge it as 2 times from the original m, right? So for original m, the length here equals to 4 squared plus negative 3 squared, that is 5. So after you magnify it for 2 times, so the total length here equals to 10, right? Okay. Or you can also say 2m can be written as 8 negative 6. So the length here for 2m is square root 8 squared plus negative 6 squared. That is for square root 64 plus 36 equals to 10. That is for the third problem. And for fourth problem here is that find the length and the line segment joining the point 1, negative 3, and 6, 9. Okay, so we can say here, the length here, we can just try to draw the graph. Like here is 1, negative 3, and for 6, 9, you can just try to set the vector here equals to 6 minus 1 and 9 minus negative 3, right? that equals to 5, 12, okay? So then you can use in the formula like square root 5 squared plus 12 squared that equals to 25 plus 144 that equals to 13, okay? That is for first problem. And for last problem here, because the vector x8 has a magnitude of 10, so you can just written that as x squared plus 8 squared square root equals to 10. So here we can say x squared plus 64 equals to 100, right? 2 times we make a square on each side. So here is square, here is square, okay? So we can just x squared equals to 100 minus 64 equals to 36. So x equals to 6. And also we have to remember that because -6 squared or -6 times -6 also equals to 36, right? So x here equals to 6 and for -6, okay? That is for the x value right here, okay? Yeah, so that's for the magnitude right here. We can set as the possible values of x, that is 6 and -6, okay? So that's the magnitude right here. I hope you can understand for how to calculate the exact value and exact magnitude, okay? So see you next time. Bye.